Okay, so the first thing we're going to talk about this week are angles and basic aspects of trigonometry. So the first thing that you need to know is that all of radians are based off of the knowledge that arc length is equal to r theta, where theta is measured in radians. So theta is it's more of like a lengthy kind of a measurement than an angle kind of a measurement, right? Because theta is actually equal to s divided by r, and s is an arc length and r is the radius length. So from that we can deduce that 2 pi radians would be equal to 360 degrees, which you can follow from this logic here, the fact that circumference is 2 pi r, circumference being the arc length of a whole circle. And when the unit circle's radius is 1, then circumference ends up being 2 pi. Circle's 360 degrees, so therefore 2 pi is equal to 360 degrees. Or if we cut that in half, pi is equal to 180 degrees. So anytime you want to convert radians to degrees, for example, let's say I had 15 radians and I wanted to make it into degrees, all I would need to do is use a conversion fraction to multiply this to the radians to get the radians to cancel. So I know that 180 degrees is equal to pi radians. And so by multiplying by that conversion fraction, the radians units will cancel. So I end up with whatever 15 times 180 is divided by pi. And that's now going to be in degrees. I don't really care what that number is, but that's what I would do. So pi is just the number in your calculator, right? It's 3.14, whatever, 22 sevenths, right? And likewise, if I was going to go from degrees to radians, for example, if I was talking about 50 degrees, to make that into radians, I would multiply by pi radians is 180 degrees. So the degrees unit cancels. So here I would end up with 50 over 180 pi in radians, and 50 over 180 can be reduced to 5 over 18. And most people would just leave radians in terms of pi. Okay, so that's the conversion part of it. Second, there are 6 basic trig functions that you need to know about: sine, cosine, tangent, cosecant, secant, and cotangent. These are used for a right triangle. In a right triangle, you have some angle theta that we're talking about here, and we have 3 sides: side length A, side length B, and side length C. Whenever I'm talking about sine of theta, I would compare the opposite side to the hypotenuse. The opposite side is A, the hypotenuse is C. So you can see that sine of an angle is the ratio of sides. Cosine of an angle is the adjacent side over the hypotenuse. The adjacent side here would be B, the hypotenuse would be C. And tangent of theta would be the opposite side over the adjacent side. The opposite side is A, the adjacent side is B. Cosecant is the reciprocal of sine, so since sine theta is A over C, cosecant theta would be C over A. Secant theta is the reciprocal of cosine, so since cosine is B over C, secant is C over B. And cotangent is the reciprocal of tangent, so this would be B over A. An example where you would use this, if you're given that cosine of x is 1/3 and x is between negative pi over 2 and 0, find the 6 trigonometric functions of x. So first of all, let's draw a picture. So I'm going to make a right triangle. I'm going to put on this right triangle an angle x. And I know that cosine is the same thing as adjacent over hypotenuse. So I know that the adjacent side to x needs to be 1 and the hypotenuse needs to be a 3. I also know I can find the missing side because 1 squared plus the missing side squared equals 3 squared. That's the Pythagorean theorem. So y squared equals 9 minus 1. So y would be square root of 8, which is 2 square roots of 2. Now I can go ahead and write these 6 trigonometric functions of x. So sine of x would be the opposite side of x, so 2 square roots of 2, over the hypotenuse. We already have cosine. Tangent of x would be the opposite side over the adjacent side, which we could simplify. And then we have also the reciprocal functions. So cosecant x would be 3 over 2 square root of 2, which you could rationalize or leave. Secant of x would be cosine reciprocal, so that would be 3 over 1. And cotangent of x would be 1 over 2 radical 2. You also should be pretty fluid at this point with 30, 60, 90 triangles and 45, 90 triangles, so that anytime I ask you for anything like sine of 45 degrees, for example, you should know automatically that that is square root of 2 over 2. Or if I asked you for, say, cosine of 60 degrees, you should know automatically that that is a half. So I would make sure that I kind of memorize the things that are in that chart. The other thing I need to point out to you is that the last problem up here says that it specifically wanted x to be an element between negative pi over 2 and 0. So I wanted to talk about what does that mean, negative pi over 2 to 0. Like, where is that? So remember that when you're drawing angles, negative pi over 2 would be referring to going in this direction, pi over 2, which is 90 degrees. So if they're asking you to go between negative pi over 2 and 0, they're asking for the fourth quadrant. So remember, in the fourth quadrant, so our answer wasn't complete above, because in the fourth quadrant, not everything is going to be positive. All of the answers I gave were all positive. So you need to remember about the situation that in the first quadrant, all trig functions are positive. In the second quadrant, all sine trig functions are positive. Therefore, cosecant would also be positive because it is the reciprocal of sine. In the third quadrant, tangent is positive, and therefore cotangent would also be positive. And in the fourth quadrant, cosine is positive, as we saw up above, and also its partner secant would also be positive. You may have heard the acronym all students take calculus, which would remind you of which quadrants were which. All, sine in the second quadrant, tangent in the third quadrant, cosine in the fourth quadrant. So if I'm talking about the fourth quadrant, the only answers that I got up above that should be positive should be cosine and secant, which they gave us cosine and we found secant. All of the rest of these should all be negative because they are being placed in the fourth quadrant, which makes them negative.